screwed something up already. No, remember I told you like anything that wasn't in this unit, I'm just gonna like tell you skip. Sake of time. I think I haven't looked at it yet. He just gives me two tasks. They're usually really similar, aren't they? In like setup at least in length. I think it's the same. Okay. This is nearly identical to what we did yesterday. You'll see when we go through the process, it's almost the same. You do need to understand the difference between the three, but really almost just the difference between the two. This one is going to be a one-way table. The goodness of fit is a one-way table. Do you know what a one-way table is? Like just one list of numbers, or one column of numbers, either way. Something like that, or you might have a list. And then your job is to like figure out if that fits what it's supposed to fit. So if you only have a one-way table, one list or one column, it's goodness of fit. If you have a two-way table, it's one of the other ones, and then it's really just about the word. And this is the GOF test in your calculator, and these two are just the regular chi-square. These two both use matrices. These are both two-way tables. Like the process is like identical. What changes is the wording. So instead of looking for are these two things distributed the same, like we talked about like stats, calc, and physics, it's like here's two variables. Are they related or are they unrelated? What's the word? The stats word for unrelated? Independent. So the stats word for related is associated. So you can write this two ways. So you can say there is no association. You're going to get like, say, height on one side and weight on the other side. You'll be like, there's no association between those two, or there is an association. So the alternative hypothesis would be there is an association. So association just means like a relationship, so it's not independent. Association actually means dependent. That's what it means. Don't put that. So no association between the two variables means that the variables are independent. No association is independent. Association is dependent. So the other way you could write this is the variables blank and blank are independent versus the variables blank and blank are. So I could put not independent. I could put associated. And then basically everything after that is identical to what we did yesterday. So I think there's just an example on the next page. We'll just do it. You got anger levels and heart disease. So I'm going to do the test in a second. We'll write everything out. But before we do that, see if you can find the expected value that goes right there. Low CHD. Remember that from yesterday. Actually, I don't know why I did too. But do you remember how to do that? That's the row total. So this one here would be 190 times 3110. So the row total times the column total divided by the total. So it's like R times C Or, remember, you can put in your calculator and do it that way too. So let's just quickly run through how to do that again. So you go second matrix, which is the x to the -1 button. And then I'm going to edit matrix A. That is not a 3x4. That is a 2x3. 2 rows going across, 3 columns up and down. And I'm putting in the observed values. And then when I run the test, remember, it's going to calculate for me the expected values. And then we'll like write everything out. So I type those in, and now I'm going to go back to matrix. No, sorry. I'm going to test, test. I'm going to, is this a chi-squared or a chi-squared GUF? It's chi-squared because it's a matrix. So I put the observed in A. It is telling me like, hey, I'm going to do the expected for you. Where do you want me to put it? We're going to say put it in B. I'm going to go ahead and hit calculate. You're going to draw whichever. And that's great. I can write that down now. I'm just going to do it again later. But what I really wanted out of that was to be able to go back and edit matrix B and look at the values. So I can A, check the one or two that I did before, and B, fill in the rest of that table. So 69.7 is what I had. That's what you had for that top left, and then let's just keep writing down the rest of them. So the idea is we would expect 69.7, we got 53. That's kind of far away. So there's going to be some like error there that contributes to the overall statistic. That's not too bad. So like just a little bit of an error. That's almost double. So that's going to be a pretty big error. Let's go through and see. So this is a chi-squared for. So you can write. It says in the problem association. You can write chi-squared for association. You can also write chi-squared for independence. It's the same idea. You can write it either way. Those two are actually opposites, but you can call it either thing. So HO would be that the two variables that I'm looking at are independent, that they're not related. So the two variables I'm looking at are heart disease and anger. So I would say heart disease, anger are independent. Or you could say there's no association between heart disease and anger. You can do it wherever you feel. So HA would, in my version, would be heart disease and anger. Or I could say not independent, or I could say associated. If you're doing the other way, so if you're doing the association, you would say they are not associated in your HO. Not as. And then you put associated here. Alright. Conditions. So does it say randomness in there somewhere? It does. We got a random sample. We need the less than 10% condition. So I'm assuming there's more than. Yes. You can. Yeah. Like I know it's different words, but they really have the same meaning, so it doesn't matter. So I'm pretty sure 8474 is less than 10% of all people with normal blood pressure. A long 5. And then, like, on a regular one, you would write this matrix that we have up here. You don't need the totals, actually. But you would just, like, take this and put it here. I don't really feel like rewriting it. Do you want to rewrite it? I think it's fine just to point at it, yeah? Okay. And then we go back. I gotta run the test again because I kind of, like, lost those numbers when I looked at this matrix, but that's okay. Now we're just doing, like, our math and our conclusion. So it's I'm just going back to chi-squared again and doing the test again, even though I already did it. Is that what you guys are getting to? Okay. So chi-squared is 16.08. They tell me my p-value, but I have to pretend that I don't really know it. So what do I use to find it? Chi-squared CDF. And I'm going to go from 16.08 to 999. If I type that in, my calculator is going to give me an error because you're not giving it all the information that it wants. So what do you still need to include there? Degrees of freedom. So you subtract 1 from the rows, 1 from the columns, and multiply them together. So 3 by 2 becomes 2 times 1. So the degrees of freedom is 2. And then that is, so it's 3.228 times e to the negative 4. So it's really 0.000329, let's say. So it's really small. I forgot yesterday to make a graph. We should make a graph. So you put your chi-squared statistic over here, and then this is your p-value. It's like the size of that area there. I am missing a conclusion. I'm aware of that, but I am missing one other thing. What would I still need to put in here somewhere? Alpha, I forgot about that. So alpha is 0.05. Two other things, I guess. So write it anywhere. Like literally, you can write this in any order you want. If it's on the paper, they have to grade it. What else am I missing then? That's the conclusion, basically. They're not giving like a separate part B, you know. What? What about it? I wrote chi-squared. Keep going. Keep arguing. What do I write? I gotta write the like the formula for the chi-squared. I know. I was just trying to like push you there. So you gotta write the formula so that like, we're kind of pretending like, yeah, this is what I use. Totally. And then the conclusion. So that's a very small p-value. So since p-value is less than alpha, we reject HO. Test of the data is statistically significant. We do suspect HA is true. So we do think there's a relationship between how angry you get and your heart disease. So 6 hours last year probably just gave me tons of coronary. Question on this anywhere? It's like the same thing, right? You're just like changing the wording a little bit. Turn to the next page. There's a little guide of like how to decide which one. We already did that in the front, and I think what we talked through in the front is easier. But you're welcome to read through whatever. If you have one list, one column. You try to see how well that one thing fits in someone else. That's GOF. If you have the major C's, it's the regular chi-squared, and it's just the wording. There's two on the next, like there's two there for homework. I don't know that you necessarily need to do them both. I would do one. Let's just do number one. And then you've got, I sent out some con, and we're basically done with the unit. You're looking at a test. I don't want to give a test on Monday, so we'll do review type of stuff tomorrow and Monday. And maybe Rob for the practice test and everything, and then Tuesday will be your test. And that's the last. It should be the last game class. You will have to take home test. All of the procedures that we did. And then you might still get some grades for like practice tests. So it's not that your grade is final.